I'm here today to talk to you about Amazon Web Services and about the AWS SDK for PHP. Really quick, my name is Jeremy Lindblom. I work for Amazon Web Services, and I work on the AWS SDK for PHP. I'm also the co-organizer for the Seattle PHP Meetup group. If you want to say hi sometime, my Twitter handle is Jeremy Amaya. And an interesting thing about me is that I like to make funny faces. So some of you in the back might not be able to see this, but this is one of my favorites. Oddly enough, this comes into play later in the presentation, so keep that in mind. I had this up before the presentation started, but we're going to have a raffle at the end of the presentation. I brought today to give away a Amazon Web Services notebook and a $50 gift card to Amazon.com. So if you want to participate, please send a text message with the words join SF AWS to the phone number 480-666-8777. Does anyone still need that slide up there? Okay, I'll show it one more time, somewhere in the middle, in case you missed it. So before I dive into the SDK itself, I wanted to talk a little bit about the cloud. And so first, I ask you, what is the cloud? Anyone have a good definition for me? A marketing word. Well, that's fair. But what is it really?
Like instead of handling the computer itself, handling the resource or something. Like Amazon needs to install a system on it, but you don't think about the hard drive, Amazon can do that.
So basically, a way to have resources without having to worry about it as much. Not having to worry about the hardware. Good, I like that. Someone in the back there.
That's right. The cloud to me is a cluster of computers in various data centers, so you don't have to worry, it provides all the redundancies, you don't have to worry about if any individual server fails.
Cool, I like that. And I think everyone was able to hear him because I could. So I came up with my own little definition based off of some words on the Amazon Web Services website, combined with some things from Wikipedia and then some things floating around in my own head. But I define the cloud, when I talk about the cloud, I mean cloud computing. And I call it the acquisition and use of computing resources that are delivered as a service on an as-needed basis. So when we talk about computing resources, what exactly does that mean? CPU. Sorry, what was the other one? Memory. IOPS, bandwidth. So a more appropriate question might be, what isn't a computing resource? Because it can be a lot of different things. But when we deliver them as a service, we're talking about delivering or providing these resources through a web service or an API in a way that's consumable and programmable. So for example, this is a code sample that uses the PHP SDK. And here I'm actually writing some code that will provision for me a web server. Basically, to do this, I'm using the Amazon EC2 web service. So I create an EC2 client. I tell it to run instances. I give it some parameters. It does stuff in the cloud somewhere. And then when it finishes, I'm able to find out basically the DNS or IP address for that server that was created for me. Do you have a question back there?
Yeah, is this a package available for your user?
Yes, it is. I will show you some more about this as we go on. So the other part of this definition was the as-needed portion. And this is really where I think the cloud is pretty cool. In traditional or self-hosting, you basically have this this problem of what type of capacity you need versus what demand you have in your application on your servers. So whenever you provision more than what you need, you're paying for wasted resources. But if you don't have enough at the right time, then you run into problems where you have really high latencies or things just don't work at all. One of the main points of using cloud computing is to alleviate that problem by scaling up and down as needed to always have the right amount of resources for you. So Amazon Web Services is a cloud service provider. If I could create my own tagline for Amazon Web Services, it would probably be something like this: bringing you the cloud since 2006. But that's kind of cheesy, so that's not really our tagline. So Amazon Web Services is a collection of services with various purposes. We have over 30 services. As you can see here, there's quite a few. For people who have little experience or no experience with AWS, I find that a lot of them still have heard of at least these two services, Amazon EC2 and Amazon S3. So I'm curious if anyone here has used any Amazon services besides these two. Cool, I got a few hands. I like that. And Amazon Web Services is constantly growing and developing more services and more features for existing services. In the past 6 months, the ones highlighted in green here are ones that we've added to Amazon Web Services. And also in the past year, the blue ones are included there too. So that's, I think, 11 services in the past year that we've added. And we continue to grow and add more features. If you're curious about what all these services do, you can basically lump them into 5 different categories, which are listed up here. And that's kind of how they are shown on the AWS website. But really, there are a bunch of building blocks to an application infrastructure that you can put together to develop a scalable architecture so that you can, like you said, not have to worry about what's going on. You just, once it's set up, it's there, it can grow and shrink along with the demand on your application. So in talking in specifics about PHP, one of the questions that I get often about Amazon Web Services is, well, what are all these services for? How does it help me as a PHP developer? How can I include them in my application? So just to kind of briefly show you what each of these services does, I have these listed up there. Amazon EC2 is really kind of the basic building block of web hosting on AWS. And there are some other higher level services that take advantage of EC2 to provide hosting. Auto-scaling is paired with it. Auto-scaling allows you to create clusters of EC2 instances that can either add to or take away machines as needed based on your configuration. Then AWS also has some platform as a service solutions like AWS Elastic Beanstalk, which I'm going to go into a little bit more detail about later. And also another service which is new this year called OpsWorks. And if you're familiar with Puppet or Chef, OpsWorks might be a cool thing to look into because it's set up using Chef for deployment, so you can actually use your own custom recipes to set up the various layers of your infrastructure. Let's see. For databases, there's Amazon RDS, which is for relational databases, so you can set up MySQL servers, MS SQL, and a few others. Then if you are more interested in using NoSQL, Amazon DynamoDB is a very fast NoSQL database solution. Amazon S3 for file storage. We have other services for caching, for content distribution, for DNS routing, then even more. So you've heard the commercial. There's an app for that where, well, at Amazon Web Services, there's really a service for that, a service for almost every part of your application. So including queuing and messaging, sending emails, setting up and managing workflows, load balancing, searching. Amazon Cloud Search is kind of cool. The same technology that powers the Amazon.com search engine is available to you in Amazon Cloud Search. And then data processing and warehousing. We have customers all over the world. I'm sure you recognize some of these logos. And there's a few more that I was thinking about that weren't on that image. I also wanted to share with you a few fun facts about AWS. So we store in S3 over 2 trillion objects, which is more than 5 times the amount of stars in the Milky Way galaxy by scientist estimates. So it's a lot of data in there. Something else interesting, last year the movie Flight was the first movie to have its visual effects rendered entirely in the cloud. That was done by a company called Atomic Fiction, and they do all of their rendering in the AWS cloud. Reddit actually runs entirely on AWS, every aspect of it. And last year when they did the Ask Me Anything with President Obama, they had to ramp up their infrastructure to be able to support the amount of traffic. And they're able to double their entire capacity in 10 minutes with AWS. Also, NASA is one of our customers, particularly with the Mars Curiosity project. They use AWS to process and store and distribute images that they get from Mars, which I think is really cool. That just blows my mind. So now that you know a little bit about AWS, you're probably wondering, okay, well, how do I actually use all that stuff? Because it sounds cool, but what do I actually do with it? Before I get into that, is there anyone who didn't get a chance to join the raffle yet? You can raise your hand so I can see. Okay, so at the end of the presentation, I'm doing a raffle. We're giving away an AWS notebook and a $50 Amazon.com gift card. So if you want to join up for that, send a text message, join SF AWS to that phone number up there, and then we'll draw the winner at the end. Okay, so back to how do I use AWS? So that we have several tools that can help you in several different ways. So the first and what a lot of developers interact with the most is probably the AWS Web Console. So there's we have in the website you can log in, you can manage your services from the management console. Also we have brand new this year that you can see the icon on the right here. There we have an iOS app for managing a subset of your AWS resources, particularly with EC2. And so they're continuing to iterate on that application and add more functionality. Now, I work for a team called the SDKs and Tools team at Amazon Web Services. So we publish a set of tools for programmers to use to interact with AWS. And so we publish 8 different SDKs right now. So there's the PHP SDK, which I work on, and also Michael Dowling here. He's going to raise his hand. Yeah, he's my buddy. We also publish SDKs for Java, Python, .NET, Ruby, Node.js, iOS, and Android. And we also do a set of Linux CLI tools, which actually you can use on any platform, as well as Windows PowerShell tools for .NET developers. And then we also have plugins for Visual Studio and Eclipse. So we have a nice suite of tools here to work with Amazon Web Services. And I'd also like to note that we are hiring right now. So if this kind of stuff sounds interesting to you and you want to work on our team, come talk to me, and we'll go from there, because we are looking for good people. So in general, the SDKs, regardless of language, kind of have some features in common. Basically, they're a suite of HTTP clients meant for interacting with each of the web services. They handle input and output serialization, so regardless of whether or not it's XML or JSON, you don't have to really worry about that. It handles authentication, error handling, and all of the projects are open source projects. You can see all the source code and contribute if you want to on GitHub. We have everything available there. So it's github.com/AWS. You can see all of our SDKs. And each SDK also has some language-specific conveniences. So for the rest of the presentation, I'm going to talk about the PHP SDK, because that's the project that I work on and that I'm most familiar with. And we're all PHP developers here, right? Okay. Unless I went to the wrong conference, then I'd be in real trouble. So the PHP SDK, github.com/AWS/SDK-PHP. And that is a lot of three-letter acronyms. It's quite a mouthful, but that's the name. Some features specific to the PHP SDK. It's designed for PHP 5.3 and up. It's PSR compliant, if you're familiar with the PSRs done by the PHP Fig group. The SDK can do persistent connections, so once you do the first SSL handshake with the service, so you can reuse the same client and not have to redo that step again. Also, we support parallel requests using curl multi-handles, so you can send multiple requests in parallel. We have event hooks, plugins, and wire logging integrated into the SDK. The inputs and outputs are basically associative arrays, so they're really easy to work with. Then we have some other features, iterators and waiters, and some other helpers. I'm going to kind of go into more details about those in a minute. And the cool thing about the SDK is it's built on top of an existing open source project called Guzzle. And a lot of the features of the SDK are actually a result of building on top of Guzzle. So Guzzle is an HTTP client library and framework. And it's used in other projects like Gout, the SDK, and it's actually going to be a part of the core of Drupal 8. It really serves as the foundation of the SDK, and it uses the Symfony 2 event dispatcher very heavily to integrate with all the parts. So it's also really easy to extend that way because you can register event listeners on there and kind of throw in your own logic as needed. And Guzzle is actually developed by Michael Dowling, my friend again. He's raising his hand right there. And he's doing a presentation about Guzzle itself right after this, after the break. So if you're interested in checking that out, I'm sure he won't mind talking your ear off too. So to use the SDK, here's a quick example of creating an Amazon S3 client and then uploading an object to S3. So at the top there, you'll see require vendor autoload, which is the composer autoloader, of course. Someone had already mentioned that. So we publish the SDK as a composer package. To instantiate the SDK, you can use the factory method of the client, pass in your AWS credentials, and then the third code block there is using the S3 put object operation. You specify a bucket. When bucket's basically a container for objects or files. You specify a key, which is the name of the file that you're uploading, and then the body is the actual content. So with the SDK, you can actually just use like a file handle, and it'll take care of uploading that for you. So again, we publish the SDK as a composer package, and we actually recommend using Composer to install the SDK. It's the easiest way in our opinion. But we also have a pair package. We offer a FAR download and a zip download if you want to just grab the source. So I wanted to kind of dive into the concepts of the SDK so that you can learn how to use the AWS SDK better. And thus the title of my talk, Getting Good with the AWS SDK for PHP. So first we have the client factory, which you saw in the previous code example. Factory method just accepts an array of parameters, including your AWS credentials, and also In most cases, you need to pass in a region as well. So AWS has services in multiple geographic regions across the world. And so those are basically, there's different data centers in each of those regions, and they're isolated from each other. So when you provision your resources, you want to select the region that you want to provision them in. And usually the best practice is to use a region that is physically closest to the whoever's going to be consuming the services. We also have a service builder or a service locator type aspect of the SDK. So you can instantiate a service builder object with the same credentials, but then each of the service clients can reuse the same credentials. So you can create a client using the get method there at the bottom. And if you create the same client, it'll actually store the same instance. So you can reuse that in different parts of your application, like a service container normally does. And that way you don't have to spend the time and memory to instantiate another client again. So commands are really kind of the basic part of the SDK. So a command encapsulates an operation to AWS and contains a request and response object. And you use the command and set your parameters on there. And then when you execute the command, it returns the data from the response. We refer to this as a modeled result. So there's a shorthand way to use the command which completely encapsulates the entire command process. And basically, you just run the name of the command as a method on the client, and then it gives you back the results. Very straightforward. But you can also do some other clever things if you want to kind of drill down and actually interact directly with the command objects. So instead of just calling the operation by name as a method, you'll say get command and then the operation name. And then you can use, there's methods for setting parameters, but also the commands also implement the array access interface, so you can kind of use it as array as well. Then you can call get result to get the data back. But then you can also, from the command object, get access to the actual request and response object. So that way you can look specifically at things like headers and status codes if you need to do something like that. Another cool thing is that the command objects, if you're using the actual object, you can execute an array of commands at the same time. And that's how you use the parallel requests feature of the SDK. So in this case, I'm creating two put object commands, which I'm going to upload two different files, but I'm telling the SDK to perform both of those uploads simultaneously, which would end up being a lot faster than doing it serially. Okay, so let's take a look at the modeled results as well. So when you execute a command, you get back modeled results. And these are also an array-like object. They implements the array access interface and iterator interface. But it follows a schema that's defined by each service's service description. So in the SDK, you have the client object, and there's actually a configuration file for the client object that gets pulled in automatically to the client that defines all the operations and responses, and also drives the documentation as well. So the schemas for the responses are defined in there, and they show up in the documentation. And you can even, from the model object, you can get access to the schema defined as an object tree if there's something cool you're doing with some meta programming there. I don't know. So along with the array access, there's also some convenience methods like getPath, which is kind of cool because you can define path to like a deeper array value, and it'll get that for you without doing any missing index errors. And then you can just convert it to a straight array if you want to work with it that way. Waiters are let's see. Actually, I wanted to ask this question earlier, but so who has actually used the AWS SDK already? Okay, and have you used the first or the second one? Who's used the version 1 of the SDK?
Yeah, version 1.
Okay, and then who's used version 2? Okay, so waiters are actually a new concept in version 2 of the SDK. There's a lot of operations in Amazon Web Services that kind of follow the eventual consistency model. So you send a request to the service. So in this example right here, we're sending a request to S3 to create a bucket or a location for us to upload files. And the service will return back to you and say, okay, I'll create a bucket. But it doesn't mean that when it returns back to you that it's ready to go right that second. There's often a delay, and it's kind of an unpredictable delay as well. So we added a feature called waiters where you can instruct the code to basically just sleep and keep checking to see if that resource is available. So that way, if you're doing something in your code where you're creating something, but you need to actually use it right there within the same context, you can actually wait in your program until that's available so you don't get any weird errors that way. So we thought that was kind of a cool feature to add and to help people get around that problem. We also have a feature called Iterators in the newest version of the SDK that allow you to iterate over entire result sets. So most of the AWS services and really other web services by other companies and providers will have APIs that return a fixed number or up to a certain amount of results, even if there's more, and might provide like a token or a marker or a number that can be used to write a second request to get more data. Similar to paginating through a database result set with limits and offsets. So the hard part is that it's often pretty bulky and ugly code to do that when you're just wanting to get a whole result set. So we created a feature to handle that for you. So when you do the get iterator function, as you see up there, it works the same way as get command, but instead of returning a command object, it returns an iterator object, which actually implements the SPL iterator type interfaces. So then you can just for each over that object and get each of the items or resources you're trying to get one by one until the entire set is exhausted. So the cool thing is that in version 1 of the SDK, to have this type of functionality, in this example, we're doing a DynamoDB scan operation, which basically is an operation that looks through all of the items in your DynamoDB table and returns them to you. But you have to do multiple commands to get all the values. So doing that in version 1 of the SDK was kind of tedious and ugly and not very fun. It's just a bunch of boilerplate code that you have to do in a loop. And we didn't really like that. We thought we could make it a lot easier. So in SDK 2, you can use the get iterator function, which and then for each over it, without having to think about what tokens and markers you need to pass in. It makes it a lot easier to work with and requires way less code to even deal with. And so that makes me really happy, just like this monkey. So also in the SDK, we have events and event listeners. And this is powered by, again, the Symfony 2 event dispatcher. So if you're familiar with how to use that already, you can take advantage of the events broadcasted by the SDK, and you can hook into various parts of the request process if you need to do something extra. And we put these event slots in almost every part of the SDK, and that way you can kind of hook in and apply your own behaviors. A great thing about events is that you can inject the logic without having to extend the class, let's see, yeah. So it's pretty easy, straightforward. We used the event listers actually to implement plugins for the SDK, and they're basically just Symfony 2 event subscribers. That's what the plugins are. And for example, in the SDK for signing requests, for authenticating the requests, it's actually just a event listener that listens for the event that's broadcast that says, hey, I'm about to send the request, and then the event listener captures that event, signs the request, does the hashing it needs to do, and then lets it continue on its way. And we inherit a lot of built-in plugins to the SDK from the Guzzle library, including this one here is for wire logging. So you can attach this wire logger very simply by doing add subscriber, and then it'll output the full request and response bodies as you're making requests to the AWS services. So that's a quick and easy way that method you can use for debugging requests and making sure the parameters are going through and that you're not getting any weird error messages. So also in the SDK, we ship some higher level abstractions that kind of, we're continuing to add more, but targeting certain use cases. So there we have a S3 multi-part uploader, which I'll show you an example of here in a minute, that kind of abstracts the whole uploading large files that normally has to be done in multiple pieces, kind of makes that a lot easier to work with. We also have things like the DynamoDB session handler, so you can register the session handler such that you can store sessions in DynamoDB. And we also have some third-party modules that we've been working on. So we actually publish a Silex service provider that integrates with the SDK, and also ZF2 and Laravel modules. I would like to do a Symfony 2.1, so if any of you are interested in helping out with or contributing that, come talk to me, because I would love to have somebody's help. So I can show you some code examples from these three particular ones here. So the Multipart Uploader, like I said, is for uploading large files to S3. Normally, S3 recommends for files that are larger than 100 megabytes that you should upload them in pieces. And there's a separate API where you initiate an upload, then you upload a piece, and you upload a piece, and upload a piece, and then you complete it. And so that's kind of, it's not particularly easy to work with in my opinion. So this object allows us to do that much easier. You just instantiate the builder object, you tell it which S3 client you're using, you tell it where to get the data from, where it goes, and that set concurrency parameter is actually, will instruct the builder to do that in parallel requests. So you'll be uploading 3 pieces at a time until you've uploaded all the parts of your file. Another cool abstraction that we have is the S3 stream wrapper. So how many of you were here this morning for Fabien's keynote? So he talked a little bit about stream wrappers, and so this is actually the same thing. You register this stream wrapper to work with the S3 protocol or scheme, and then you can use PHP's normal file operations with S3 resources just as if it were part of your local file system. So once you register the wrapper, you literally can just do things like fopen, fgets, and it just works. You're working with files in S3. Another cool thing is that this stream wrapper allows you to integrate directly with Symfony's Finder component. So once you register the stream wrapper, you can use the Finder's cool file locating API, and it'll just work. It'll return all of the S3 objects that match your request. So are there any questions so far about some of the code samples here? Sure.
On that stream wrapper, directly accessing files from S3, I have the impression there's latency.
I'd say there probably is a little bit of latency as compared to what's happening directly in your file system. But one of the cool advantages of it is that you don't really have to know anything about the S3 API when you're working with S3 objects. You can just work with it like a normal file. Well, the Finder is part of Symfony. The Finder is a Symfony 2 component. So because we have the stream wrapper registered, Finder works with PHP streams, so it just works just like you would expect it to. So I want to take a look at a sample application here, and I told you the funny face thing was coming back into play. Well, this is the part where it comes back. So I want to make a funny face sharing app where you take pictures of funny faces and post them. Something pretty simple. This is a screenshot of the actual application that I wrote here. And so there's that page that shows the pictures, and then another page with the form for uploading a picture and adding a caption. And as you can probably tell from the buttons, I am using Twitter Bootstrap for the UI there. So for this application, we're going to use a few different AWS services, and I'm going to talk about how exactly these are used in the context of this application. We're going to use AWS Elastic Beanstalk, which is one of our platform as a service solutions for hosting this application and making sure that it can scale. We're going to use Amazon S3 to store the photos. We're going to use Amazon DynamoDB to basically index the photos and store the caption. And then another service called AWS IAM, or Identity Access and Management. And that's a service that basically is for access control to your AWS resources. So we're going to use that in a cool kind of way that I'll show you in just a minute. So first of all, more about Elastic Beanstalk. Elastic Beanstalk is a really easy way to deploy a scalable web application, and it's probably one of the easiest ways to do it with AWS. There's not a whole lot you have to do to set up for that. So we have a PHP 5.3 and a PHP 5.4 stack available on Beanstalk that you can choose from. Elastic Beanstalk actually leverages our other services. So it uses EC2 for the actual servers. It uses auto-scaling to allow it to scale up and down. It uses the Elastic Load Balancer service to handle the load balancing to those various instances. And also CloudWatch, Amazon CloudWatch, for monitoring those instances, keeping track of CPU and memory usage that then can trigger the auto-scaling to scale up or down. Also uses Route 53 for domain name management, but I didn't actually put that one up there. To actually deploy your application to Elastic Beanstalk, you can either use Git to push to a specified endpoint, or you can just upload a zip file of your application to Elastic Beanstalk, and it'll deploy it on the servers for you. Elastic Beanstalk, unlike a lot of platform as a service solutions, allows you to still get access to all of the instances. So you can, when you create a Beanstalk application, you set a key pair that you can use to then SSH into those boxes. So if any reason you need to get access to a box, you can SSH into it. There's also configuration files and hook scripts that you can put into your application to modify various parts of how Beanstalk works. So I'll leave that up to you as an exercise if you want to read the documentation about that. So for our application, we're going to do a little Silex application because it's pretty easy. The code's small and easy to show on the screen. Also use Twig, though we're not really going to look at the Twig files because it's not too interesting. And then we're going to use S3 and DynamoDB from PHP to store our photos. So first up, I'm going to create our Silex app here. We're using Composer to install both Silex and AWS and Twig. Then like I said earlier, we actually publish a Silex Service Provider. So that can also be installed through Composer. So you can register that service provider on your Silex application, give it your AWS credentials, and it'll be ready to go in the service container of Silex. So here's the AWS Service Provider. It's also along there with our other open source projects, AWS/AWS-SDK-PHP-Silex. So it should be easy enough to find. So one of the things that bothers me is that we can sometimes run into a credential problem. And this isn't unique to AWS. It's not unique to Silex. It's just something that happens where you need to include credentials for something in your application, but of course you don't want to put those in version control. So this is where IAM comes into play and how we can use it to kind of alleviate this problem. So there's a few different, I guess, vocabulary words you need to understand for IAM. So we're talking about IAM roles and instant profile. So an IAM role is basically a named designation that allows you to give other AWS users or other services access to your current AWS resources. And then along with that, an instance profile is associating a role to an EC2 instance. So basically, when you set up the instance profile, you're saying to an EC2 server, okay, you have this IAM role, which means whatever you've configured that role for, you can do these things on behalf of my account. So then it produces basically a set of temporary credentials on that EC2 instance, which we call instance profile credentials. And the SDK is set up to automatically pull those from the EC2 instance. So we can basically remove the credentials from our code here. And when we deploy it to Elastic Beanstalk, it'll pick up the temporary credentials that we've configured our Beanstalk application to use. So let's look at some of the code here. So this is the index controller. So this is the page that had all my weird faces on there. So we create a route in Silex using app-get. And we're going to use, so with the service provider for AWS, you can use the app AWS to get the instance of the SDK. And then the get method off of there will get DynamoDB, will return an instance of the DynamoDB client. And then to basically to execute the query to get the information about the funny faces, I'm going to use one of those iterators because those are easy to work with. Get iterator, scan. Scan is the operation that looks at a whole table. And then tell it the table name as the parameter. So funny face table. And then for the rest of it, we're just going to go ahead and just return that iterator to our Twig template, because Twig supports iterators automatically, so there's not a whole lot of work we have to do to make this work. There is a small problem, though, with that iterator and the way that DynamoDB returns data. So when we iterate over the items, the shape of the item actually looks something like this. So it'll have the keys and the values, but interjected in between those is also these S's and N's, which are actually the types of the data. So the way that we have the code here won't work exactly how we think, because when we give that information to Twig, it's going to not iterate over that properly. So because we're using that iterator, we can actually decorate that iterator with another one that's going to handle the transformation of this data so that we can still pass it cleanly into Twig. To do this, we're going to use a map iterator, which is an iterator provided by the underlying Guzzle library. And it's basically just, as you iterate, it applies a callback function to it, to each piece of data. So when I create the map iterator, I pass in the DynamoDB scan iterator to it, and then I added a callback function there that basically just goes through this structure, and just gives me it doesn't care what the key is. I don't really care about types because I'm putting these all into an HTML document. And it just returns me whatever the first value is. That's what I'm using the array map current for right there. So using that, everything when I iterate over the values will be spit out into Twig in the right format, just what we want to display. And that is how that front page works. That's all the code that you need to make that work, aside from the actual HTML stuff. Then on the other page, the add page, I'm going to show this one in two pieces here. So we're going to map this to photos, add, route, and I'll use, again, the Silex container. I'll get the AWS Service Builder, and then get the S3 client from there. So now I have the S3 client. I'm doing a put object operation. So this would happen. I have some, comment with ... up there. Basically, what I haven't included on the slides is the Silex code needed to verify that the uploaded file is in fact good and there's no errors. So you'd have to. I have the code of that in my code, but I didn't think it was totally relevant to have to show here. So with the input object, I'm specifying the bucket where the object goes, the key, and then the source. The SDK has a shortcut. Before I showed you a body parameter. And a body parameter takes either a string of data or like a file handle. And here I'm using a shortcut, which is the source file parameter. And this I can just tell a path. So from that file object is actually what we get from Silex, which is a Symfony object for uploaded files. I just ask it what path I'm using. And then ACL sets, we can use that to set the image to be public, because normally when you upload an image to, or anything to S3, it's private by default, but you can easily flag it as being public by using we have a set of constants that you can pass in there to make it easy. And then that get object URL, so when I get the response back, I just want the URL of the object once it's uploaded. So the second half of this function is using DynamoDB to actually create a record of this. So I get an instance of the DynamoDB client. I get the caption from the request that was submitted through the form, and then use a DynamoDB put item operation, tell the table name, and then I'm going to provide the source or the URL I got back from S3 plus the caption that I got from form upload. And that's pretty much it. That is the whole application right there. And you didn't have to set up your own MySQL database. You didn't have, because you're using Elastic Beanstalk, you're deployed onto potentially multiple server instances that can scale up or down. You're storing your files on S3, so you don't have to worry about them being trapped in one server versus another. They're available to all of your server instances. And it's a very easy way to set up a scalable web application using AWS. So now it's time for the raffle. So I'm going to get this kicked off here. By the way, this raffle is actually another Silex app that I wrote on top of Elastic Beanstalk as well. And I'm using Twilio to handle the SMS interactions there, and actually Twilio is also an Amazon Web Services customer. So let's kick this off here. Oh, sorry. I forgot something. That was almost anticlimactic, wasn't it? Okay, you should get a text message here in just a second. Should. Okay, anyone? I have a 651-497-4174. Woo! All right. So I got a AWS notebook for you and also a $50 Amazon.com gift card.
Thanks very much.
You're welcome. You got one too? I'll get you something else. Come see me afterwards. I'll get you something. I don't have one of those. So actually, the real winner here is everyone because I brought $100 AWS credits for everyone here. So before you leave, come up here and get one of those from me. I got them all up here. And that's my gift for you. Hopefully you can use them to get started doing something cool in the cloud. So if that's all I have for you, go to our GitHub project, give us a star on GitHub, that'd be awesome. My contact information up there, and I'd be happy to answer any questions you have too. Thanks.
Baby, what's wrong?
Okay, any questions? Good question. I think it does. Michael, do you know that one?
It's an automatic piece of thing, and it won't be the ego. That would be like your client.
Yeah.
It has to be better straight the way you do it. So if you have a content coding, yeah, it'll allow that, and then it'll serve it back with that same header and the same.
Anything else? You did have some questions already in the middle, so that was good. Cool, yeah, if you have any other questions, feel free to come up here and talk to me. Got the credit, so come get one before you leave. Definitely take those, because that's awesome. And then also some stickers as well.
Tell me, baby, honey, what's wrong with you? Ooh, baby. Who been here, baby?